Hey grade 7s, this is Math 7 8.6, Graphing Translations and Reflections. We're going to look at translations first and then we'll look at reflections after. Very similar sorts of concepts. I need to turn my light on. Here we go. So here I have a graph I've drawn and I have quadrant 1, quadrant 2, quadrant 3, quadrant 4. You'll notice that it goes up by 1 each block or down by 1, which means that the scale is 1 for this graph. The scale is the amount it goes up for each block or each number. So here I have point A. And let's look at this. What is point A? A would be, well, we do left, right first. How far over is it left? It's 1, 2, 3. It's at -3. And it goes up and it's at 3 there. Okay. And now here we're going to talk about translations. Translations are when it moves. Okay. Translations move. They move or they change position. Translations change position, but not shape or orientation. It doesn't turn or anything. Okay. So let's just first, we're going to translate this point A, and then we're going to do something where it's a shape that we're going to move. Okay. And it says here, we need to translate A 5 units right and 3 units down. So all you do is you start here, and if the scale is 1, that means that each block would be 1. We need to move 5 to the right. 1, 2, 3, 4, 5. And 3 down. 1, 2, 3. So right here is the translation. And we call this A, and we use this little apostrophe looking thing. It's called a prime. We call it A prime. Now if we look at this, where is this point? Well, it's 1, 2 to the right. And it is right on this x-axis, which means that y is 0. Now, just to check, right is more positive, right? Just to check our answer, -3, +5, put those together, add them together, -3 plus +5 will equal 2, right? -3, +5 equals 2. That's what that should be. As well, 3. And we're moving down, which is negative. So we started with 3 and we went down how many? 3 units. Down 3 units. That got us to 0. And that's the number there. So that's just a little way to check these values that we got the right values there. Now what I'm going to do is I'm going to draw a few more points here. I'm going to make a little shape, a little, I don't know, triangle or something. And we're going to translate the other points of it. And we're going to draw it in. So here I have A, B, and C. If we look at B, where is B? Well, it's 1 to the left, so that's -1. Left is usually negative. Out of the thousands of graphs I've made, only I think 9 of them was it flipped opposite. This is the convention we follow. And how far up is it? It was 1 left and 2 up, so it's 2. Okay, and C, let's draw C as well. C was 4 to the left and 1 up, so 4 left is -4. 1 up is 1. Okay. Now we're going to translate this shape, this triangle, this shape. So if you have a shape that's just on there and it doesn't show these bigger points, just look where are the corner points. And if you translate all of those over, you move them over where they're supposed to go, according to the instructions, you will be able to then just connect the dots and your shape will be translated or moved. So B, it says to move it 5 right, 3 down. So let's go 1, 2, 3, 4, 5. 1, 2, 3 down. Okay, so that should be B prime. And we're going to take C and go 1, 2, 3, 4, 5. 1, 2, 3. It should be right there. And then we can connect the dots and compare. Do these shapes look the exact same? Yes, they do. The difference between this over here, this C and this A, was you go one right, two up. C prime compared to A prime, one right, two up. A compared to B would be one down, two right, one down, two right. So it didn't change shape, which means you translated properly. It shifted over, which means it's a translation, and it didn't turn, which means it's not a rotation or something like that. So B prime, let's just write down what the values of B prime are. It's right 4, down 1, right 4, down 1. And C prime is 1 to the right, 2 down, 1 to the right, 2 down. Okay, and we can check our answers just by taking our first value and adding 5, because that's what our instruction was. 5 right is adding 5, which would be 4, and that's what we got. And we had 2, and we're going to subtract 3, which means -1. That's our value. We've got -4 plus 5 and 1. Subtract 3. 4 plus 5 is 1, which is our value, and 1 subtract 3 is -2, which it works. Okay, so we just translated it just by moving over 5 like we were supposed to and down 3. So I'm just going to write something in here. Right or up equals positive, or adding, right? And left or down means subtract. Okay? So we were able to translate this shape over to another spot. Sometimes it'll be left, sometimes it'll be up, down, right. There's usually 2 different instructions given, but translation is just moving around. So these are translations. I could draw something else in here. Let me just draw this shape right here. This one right here could be A double prime, B double prime, and C double prime. This is another translation of these shapes, right? They look the same, they're not turned, they're the same. The position has just changed, so it's a translation. How I remember this word translation, what it means is, if you think about it, there's lots of different languages in the world spoken in a lot of different places. Yes, there's exceptions. There's certain places where there's multiple languages spoken, but there's lots of different places where languages are more common. And you know what? People communicate the same things using different languages in different places. So different places communicating the same thing. That's how I kind of remember this word translation, because you can translate from one language to another. That's just a way I used to remember translation versus reflection versus rotation, which is what we learn next. If that doesn't help, I'm not sure. You might need to just memorize it. So when doing translations, all you have to do is pick the corners or the vertices or the edges, sorry, not edges, the end points of these line segments that make up the shape. And you just translate each of those points and then just connect the dots and you'll get the correct shape. I thought this would be a good way to describe reflections, because you've probably heard of reflections based on mirrors. You look at your reflection in the mirror. Now notice when a point, let's say my fingertip is close to the mirror, the reflection on the other side is also close to the mirror. It looks like the same amount of space. And as I bring it further away from the mirror, it looks like the reflected side also moves further away from the mirror. Now what's right is still to the right side, what's left is still to the left, what's up is still up, and down, down. But the distance that I change it by changes. A mirror works like the line of reflection or the plane of reflection in a 3-dimensional space. We'll look at this on the page. All right, so let's look at this. What we're going to do is we're going to take the same shape that we used before and we are going to reflect it over certain lines. So the questions will say reflect it over the y-axis or over x equals 2 or over the x-axis. Now remember, this line going across here is the x-axis. This line going up and down is the y-axis. So first we're going to reflect over the y-axis. We're going to reflect this shape ABC, the triangle ABC, over the y-axis. So we're going to flip it over it. Imagine this y-axis is a mirror for this, okay? So simply all you do is you find your point and count how far it is away from that axis. Okay, so if we go straight perpendicular to that axis, count, it's 1, 2, 3. Okay, it was 3 there. So then from that y-axis, we'll go 1, 2, 3, and there is our A prime. Why do we do it that way? We go 1, 2, 3, 1, 2, 3, because remember in the mirror, the further my finger was away, let's say this is the mirror, the further my finger was away from the mirror, the further reflection moved away. And the distance from the mirror to your reflection or the object that it is, they are always equal. So you just count it 3 and 3. There we go. So our A prime for this one would be positive 3 now, positive 3, and it's still up 3. Notice when you're flipping over the y-axis, the x is what changes, the y stays the same. So the axes you're flipping over will stay the same. Let's find B prime. B prime, it's 1 away, so 1 away. B prime is right there. Negative became positive 1, and it's still 2. It's still the same y. The y doesn't change when you're flipping over the y-axis. C is 4 away, so 1, 2, 3, 4. Right there is C prime. So C prime is positive 4 now, and 1. Notice for all of these, our y stayed the same. The axis we flipped over was y, so it stays the same. It's the other one. Notice it just flipped sign. It just flipped sign when you flip over an axis. Now let's just draw and connect the dots here. Look at those two shapes. They're the same size. They've just been flipped over. It just flipped over. Now what we're going to do is we're going to reflect this shape, the original one, over the x-axis instead, okay? So again, count it to the plane that or this line that we're flipping it over. The x-axis, we're going to flip it over. B is 1, 2 away. So 1, 2, that's where B double prime we're going to call it, because this is our second shape that we're reflecting. A is 1, 2, 3 away. So 1, 2, 3. There's A double prime. And we're going to go C is just 1 away, so it's right here. It's the same amount on either side. So here we go. We can connect these, use a ruler, or else you get wavy lines like that. It doesn't look perfectly the same. But let's look at these points. A double prime. A double prime is -3, -3. B double prime is -1, -2. C double prime is -4, -1. Okay, now let's just compare. When we changed it and we reflected it over an x-axis, notice that our x values stayed the same. It was just our y's that switched, and notice how they switched? They just switched to the opposite sign. Okay. Now we're going to do something just a little more complicated. Things don't always just get reflected over an axis. This is bothering me. I'm going to fix this. Sometimes they could actually be flipped over other lines. Now this part of the lesson is just a little extension. It's a little extra, maybe a little more difficult than some of the things you've done. So instead of reflecting over the x-axis or the y-axis, we're going to reflect over x equals 1. Now think about it. When we flipped over the y-axis, any point on this y-axis, what is x equal to? X is equal to 0, right? Any point on here, if you drew a point here, this would be point 0 for x, right? And then positive 3 for y. So any point on here is x equals 0. Now what we're going to do is we're going to reflect over x equals 1. Okay? Where is x equal 1? X equal 1 is right here. It's this line right here. So we're going to reflect this shape. We're going to call it A triple prime, B triple prime, and C triple prime. And we're going to figure out where those points would be. Okay? It's just a little more complicated. Now, instead of counting to our axes, we're going to count to the place we're reflecting over, which is x equals 1. We're going to find x equals 1, and we're going to find how far away they are from x equals 1, and then we're going to move that way. So think about it. We have 1, 2, 3, 4 till x equals 1. So 1, 2, 3, 4. That's A triple prime. We had B was 1, 2 away. So it's going to be 1, 2. It's right in the middle of this one. So that's B triple prime. And C, we have 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. Notice the shape it makes is the same size, same orientation. It's not turned at all. The only thing that's changed is the position where it is on here a little bit. Sorry, I got confused there. It is turned, it's flipped over. I'm meaning when compared to the other reflection. So things that are reflected over y or x equals something would stay the same. So notice these are the same, these reflections are the same. Why? Because the lines they reflected over were up and down. But you'll notice that the difference, this space between this center line and these ones is the same, the distance, okay? Now here, the distance is the same for these. So you can actually flip things over different lines. You can actually even flip over diagonals, which that gets a little more complicated. So let's draw this in. A was 5 right, 3 up. B triple prime was 3 right, 2 up. C triple prime was 6 right, 1 up. Now you'll notice now we're not flipping over an axis, we're flipping over a different line on here. So this whole keeping something the same doesn't quite work out, but you'll notice that the differences between 1 and each of the values should be the same. For example, the difference between 1 and 5 and 1 and -3 would be the same. 1 is different by 4 from either of those. 1 and 3 is 2 different. 1 and -1 is 2 different. 1 and 6 is 5 different. And 1 and -4 is also 5. So the difference stays the same. Don't believe you'll see any questions like this last part, but I thought that it was a neat little extra challenge. I am going to show you one more question that is similar to one you might see on an assignment that is a little more complicated to do with reflections. All right, here's the task. We need to reflect triangle JKL over the y-axis, okay? So which is the y-axis? It's this up, down here. Okay, so we have triangle JKL, and we're gonna reflect it over this line, this up, down, y-axis. Okay, that's what we're flipping it over. So J, looking here, what's it going up by? What's the scale? 1, 2, 3, 4, 5. Well, that's 5, so that means it's a 1, right? So this is 1, 2 to the left, which is -2, and then it's up 2, so it's +2. K is 1, 2 to the right, and 1, 2, 3, 4 up, so 2, 4. And L is 1 to the right, and 1, 2, 3 down. 1 to the right, and 3 down. We're flipping over the y-axis, which tells me that my y-axis, my y value stays the same. So I'm going to just keep these the same. so I don't make a mistake, and I'm going to check this, whereas we know that the x values will flip to the opposite sign. So -2 becomes 2, +2 becomes -2, and +1 becomes -1. Now let's just draw these points on this chart or do it our way that we've already done it. If we are flipping over this one, it needs to be the same distance to it as past it. So 1, 2, 1, 2. So K prime is right here. K prime is right there, which means that it should be at -2, 1, 2, and +4, 1, 2, 3, 4, and certainly that is where it is. What about J? Okay, J needs to go 1, 2 to get to the axes that we're reflecting over. So 1, 2 past, it goes right there. So this is J prime. And J prime we thought would be at +2, +2, 1, 2, 1, 2, +2, +2. Quadrant 1 is both positives. Correct. Good. And then L, it's 1 away from it. 1, and so 1 right there. We predicted it would be at -1, -3, -1, -3. Correct. So L prime is right there. Then we just connect the dots. For the reflection, I like to use, I sometimes like to use dotted lines or a different color. But I'm just going to do this. You'll notice something here. It flipped and kind of covered over, but you'll notice that there's a line of symmetry. There should always be a line of symmetry right on that axis or the line that you are reflecting things on. There should be, it should look like the same on both sides as if it was a book opening. And certainly right here it does. So that's something, sometimes reflections will kind of overlap, and I wanted to show you that so that if you got to that point on an assignment, it would not be confusing. But remember, y-axis means that y stay the same. X-axis means x stays the same. There might be some questions that come along where you first need to maybe reflect an object and then take these primes, this shape that's made, it'll say, or the reflection that's made, and then translate that. So you might need to then maybe move that up, down, left, right, over, or you might need to translate first and then reflect. So there's a few different ways that these questions might be worded on the assignment. I hope this helps. Good luck.